of ground source drilling. We are recording live onto YouTube, and this event does go out live, but you'll also be able to catch up later on if you need to go. So Robert wants me to let you know this is a basic presentation. This is not a big technical presentation. It's the basics of drilling within our industry. So if you do have any technical questions, can I ask that you send those to admin at GSHPA, gshp.org.uk. That's admin at gshp.org.uk if you've got any very technical questions. And if you do have any questions, can we ask you not to pop it in the chat? Can you pop it into the Q&A that's at the bottom of your screen? And as the presentation is going on, if you pop your questions into Q&A, I'll keep an eye on that, and then I will put the questions to Robert when he's finished. So that's me done, making mistakes as well. So Robert, it's over to you. Thank you.
Thank you, Andrea. Okay, so let me just share my screen and make it full. Okay. Hopefully you can see my screen okay.
Yep, that's fine, Rob.
Okay, full screen, yep.
Yeah, that's fine.
Okay, great. So hello to everyone, and thanks for joining. As Andrea mentioned, what I want to do today is just go through some of the basics a little bit of ground source, and also touch on the role of the drilling contractor a little bit as well. The angle I'm coming from really is that to many of us in the sector who are used to heat pumps, they've been around for several years. Awareness of the technology is rising pretty quickly, but at the same time, to many who are perhaps on the outside, whilst they might have heard of heat pumps, they might not be too familiar with them, or indeed why they're being so strongly endorsed as the heating technology of the future. So today I'm going to go through things in layman's terms a little bit more, and you can probably tell as well by my accent that I'm from north of the border. So today's presentation will have a slightly more Scottish slant on it than perhaps previous presentations. Before we go on, just a quick introduction to us. I work for Hydrocrat. We're a borehole drilling contractor based in Scotland. You can see a nice picture here on the screen of us drilling just south of the Forth crossings, which are in Edinburgh. Founded in 1960, as you can probably tell by the image which is on screen, we go quite far back. Setting up shop 1960, and that image, for anyone that's interested, is actually from Millport on an island just off the west coast of Scotland near Glasgow in the mid-1960s. We're based in Motherwell, which is slap bang in the middle of Glasgow and Edinburgh, and we've got a fairly significant history in drilling in the energy and water markets. So you could say that an involvement with ground source and geothermal systems was a natural fit for us. We also design and build our own drilling rigs in-house, which is a little bit of a rarity these days for a drilling contractor, but something that we're very proud of, and we're proud to use them on sites across the country. Anyway, enough about us. Why are we talking about ground source? Well, we're talking about ground source because of a problem we've got with climate change, which is driven by human-induced emissions of harmful gases into the atmosphere. The consumption of fossil fuels, such as gas and oil, are big contributors to these emissions. Therefore, governments are working out how to phase out these fossil fuels and bring in technologies which are more environmentally friendly in an effort to try and tackle global warming. Focusing on Scotland here, the Scottish Government's aiming to achieve net zero by 2045. And for those of you who don't know, net zero is essentially achieved by balancing harmful greenhouse gases which we emit into the atmosphere with the gases which we remove from the atmosphere, so trying to reach a zero stage basically. One of the most significant culprits of these harmful emissions in the UK at least are the heating systems which we use, which, as many of you will know, predominantly use gas or oil systems, particularly in more densely populated areas where those services exist. So the Scottish Government has now stated in the last couple of months its aim to transition 1 million homes to low and zero carbon emissions heating from 2030. And you'll see from the new snippet on the right-hand side, that one of their core strategies to move this process forward is by mandating that low carbon heating systems are installed in new build homes, which in effect acts as a ban basically to fossil fuel systems such as gas from that point. Heat pumps come in because they tick the box of a low carbon system, essentially because they harness the heat from a source which already exists, as opposed to burning some sort of fossil fuel in order to achieve that heat. So in terms of efficiency and cost of the heat pump, tackle the efficiency question first of all. A typical heat pump system is typically, in terms of efficiency, that's typically indicated through what we call a coefficient of performance, or COP as it's known within the industry. And that basically indicates the amount of units of heat which a heating system generates for every unit of energy which it consumes in order to generate that heat. And in the case of a ground source system, a well-designed system that is, it can usually achieve a COP of between 3 and 4. What that means is that for each kilowatt of electricity which is used to run the heat pump, approximately 3 to 4 kilowatts, sometimes more than that, of heat can be delivered to the property. So in other words, this means a well-designed ground source heat pump system is in effect about 300 to 400, if not more, % efficient. Oops, sorry. Just to contrast that with a typical gas system, for a gas system, you're typically talking about 85 to 90% efficiency. So you can see the difference there compared to a heat pump. In terms of costs of an installation of a ground source heat pump, those can vary depending on the requirements of the individual property. But if you take an installation of a typical household, you're generally going to look at between 14,000 and 20,000. But as I say, if you want to get a cost for your own property, it's best to speak to an installer, an accredited installer who can advise on that and give you a more concrete price. In terms of running costs, those can vary depending on the size of the property, the level of insulation, so on. So it's hard to define those. I should also stress, however, that there are funding opportunities which are available, and one of the most prominent of those is the Renewable Heat Incentive, or RHI, which was developed through the UK government and is administered by Ofgem. The RHI scheme, specifically for installations for renewable heat in homes, is called the domestic RHI, where you can apply for and receive quarterly payments for up to 7 years. And I believe, if I'm right in saying, that the deadline for those new applications to come in for RHI is the 31st of March 2022. So if it is something that you're looking to do, it's best to get the ball rolling on that, speaking to an installer as soon as possible. There are further funding opportunities for grants, loans and so on for those sort of installations. I know that in the case of the Scottish Government, they are constantly promoting loans and grants for installation and research projects. So the chances are that there are other funding opportunities that you can look at. Just before we move on as well, you'll see the graph on the right-hand side. And what that does is it indicates the savings when you install a ground source system that you can make in terms of tons of carbon dioxide per year for an average system. So if you take an average oil heating system, for example, you could save approximately 4,000 kilograms of carbon dioxide per year in terms of emissions, or 4 tons. So what is ground source and how does it work? Well, essentially, thermal energy from the sun is soaked up in the earth, and that basically provides us with a nice, readily available and renewable source of heat. At shallower depths, down to about 200 meters below ground level, the temperature in the surrounding rock is typically around 9 to 12 degrees Celsius, in Scotland at least. And one of the questions that I'm sometimes asked is, well, what happens to the temperature in the ground during the winter when it's colder? Well, generally, when you go to deeper depths, perhaps with a borehole, as we'll cover in a minute, generally when you go deeper, the ground temperature will stay relatively consistent throughout the year. So there is consistency, and you're free of the risk of changes in weather and time of day and potential seasonal fluctuations from winter to summer. Okay, moving on. So the next question is, well, how do we actually extract the heat from the ground? Well, there's several ways to do that. Covering first at the horizontal way of doing it. This is through pipes known as collector loops, which are laid horizontally in shallow depths beneath the surface outside of the home. These can either be laid, as is shown on the screen, either in straight pipes or in coiled pipes of loop known as slinkies. In terms of the straight pipes, they're usually laid probably about 1 metre or 2 underground, usually laid in parallel as much as possible to maximise the space. The other way to do it, as is on the right, is through loops of pipe, otherwise known as slinkies, as I've already said. And you can see here on the image that there are 2 runs of coils in the example on the right. And to elaborate slightly, each run would typically be laid in a shallow trench, which would be about 1 metre wide and at 1 metre depth for each individual run of coil. Once installed and operational, the loops have liquid inside them containing antifreeze, and those would be circulated through the pipes, essentially harnessing the heat from the ground. Generally speaking, a horizontal solution will be a bit cheaper to install than a vertical solution, as we're going to cover in a moment. However, as you can imagine, with a horizontal solution, it will require more land in order to achieve the heat requirement for the property. And that's land that you can't then use for buildings or even things like tree planting afterwards. So it is worth assessing the merits of that versus a vertical system before you decide to go with an installation. Just also to highlight as well that there are standards for the Ground Source Heat Pump Association that they have in place, and it is important that any installer or contractor involved in an installation follows those guidelines. Effectively, those are protections in place for the homeowner to make sure that they get a well-designed system. In terms of vertical methods of heat extraction, and this is where we as a borehole drilling contractor would come in, that there are 2 types of vertical system typically. The first of those and the most common of those is the closed loop system. Effectively, how that works is through boreholes being drilled into the ground to depths of up to usually 200 metres below ground level. And typically those boreholes will be drilled in a diameter of about approximately 120 millimetres, which is 4 3/4 inches. Once the borehole is drilled, basically 40 millimetre pipe is installed within that borehole, and you can see the picture on the left-hand side of the screen there, showing the bottom of the loop, basically where the liquid would circulate down to the bottom of the U-bend and then be circulated back up towards the surface again, harnessing the heat as it goes. Again, those are installed in compliance with the vertical borehole standard, which the Ground Source Heat Pump Association has, effectively to ensure good standards for the industry are met for the installation of these systems. In terms of an open loop system, it's a different type of system. In the same way a borehole is drilled, it could be in a larger diameter than the 120 millimetres that I mentioned before. And the objection of an open loop system is basically to harness the heat from the actual groundwater, which is underneath the ground, typically accessing the water from an aquifer or through historic disused underground mine workings. And the idea basically is that the groundwater will be pumped to the surface from the abstraction borehole. There will be a borehole designed for abstraction purposes to the surface. That water will be abstracted from the borehole, circulated to the heat pump in order to harness that heat, and then will be discharged at a lower temperature later on through a different re-injection borehole, being careful to space far enough away so that there isn't thermal interference between the 2 boreholes. Again, there are standards in place. In terms of an open loop system, it's important to comply with the code of practice developed jointly by the CIBSE, the Ground Source Heat Pump Association, and also the Heat Pump Association as well. So we've covered what we can do to harness the heat, but what about the heat pump itself? And obviously, as a drilling contractor, there are people that are more qualified in some senses to answer questions about this, but just to give you a brief overview of how they work. Typically, the heat pumps are located inside of the property, and as we've already mentioned, the heat pump is powered through electricity rather than through any involvement with fossil fuels. Aside from the heat for the home or the property, it can also provide you with hot water as well. And in terms of size of the heat pump, again, this will generally depend on your property, and the most critical factors will typically be the size of the property, the level of insulation in the property, the size of the distribution system, so that would be either radiators or underfloor heating systems traditionally, and also generally what kind of indoor temperature you want to achieve within your property as well. Generally speaking, the larger your heat requirements, the higher the power output is going to have to be for that heat pump. A typical house will usually require a system with a power output rating of about 10 to 12 kilowatts. Again, that can be higher or lower depending on the requirements for your property. Another question we're often asked is, well, what size do those heat pumps typically take? The dimensions of the heat pump can vary quite a lot depending on what the property requirements are. You can go from smaller solutions, which can basically be fit inside cupboards, to larger solutions, which need to be fit inside a specialist plant room, which houses all the equipment. So just in terms of the heat pump itself, well, how does it actually work? Well, the easiest way to explain it is that it's basically a fridge in reverse. It's powered through electricity in your home, and basically it enables the pump to work and extract the heat via the collector loops that was recovered, which are installed either horizontally or vertically. That will harness the heat through those loops in the ground. As I've mentioned, an antifreeze liquid solution is basically circulated around those collector loops, harnessing the heat as they go. The liquid's basically warmed as it goes through the collector loop, and then as it goes towards the heat pump. This liquid then goes up to and through an evaporator, where it meets a refrigerant which is being circulated inside the heat pump. That refrigerant is then evaporated into a gas which is condensed, and that causes it to become hot. And that's what's then circulated towards the distribution system, such as the radiators or the underfloor heating, along with your hot water. After the heat pump itself, there's typically a supply and a return pipe which goes from the heat pump towards the collector loops. Those supply and return pipes will typically go into a manifold chamber, and from there, that manifold chamber, that basically serves the purpose of connecting the collector loops, for example, 3 or 4 boreholes together, so that those can go into the supply and the return pipes. So that's a little bit about the heat pump and the generals of ground source. What I want to cover just briefly is the role of the drilling contractor, the sort of part of the puzzle that we at Hydrocrat tend to fit. Generally, in terms of the preparations, a drilling contractor, obviously they'll be contracted to put in a closed loop or an open loop system for ground source heat pumps, and typically the drilling contractor will work with a designer or an installer who will engage the services of the drilling contractor in order to provide that as part of a turnkey solution. Generally, what will happen is that the installer or the designer will give us, the drilling contractor, the scope of the work. That is the number of boreholes which are required, the depth of the individual boreholes, and perhaps specification of the materials which have got to go within those boreholes. There will also be a consideration of the drilling conditions, for example, the geology, and then also on top of that, any other obligations which might exist, such as environmental regulations or any requirements with the coal authority. What will then happen is that the drilling contractor will prepare a price for the drilling based on that scope of works. They'll then agree that price with the installer or the designer, which will enable works to then start on site. And obviously, before work start on site, the drilling contractor will prepare the necessary documentation, such as the health and safety, risk assessment, and the method statement, or consider any underground services which might be feeding the property. In terms of the practicalities, whilst on site, what we'll typically need to do is consider various different factors before we actually mobilise the site. We'll need to consider, and the image on the right is as an example of the sort of thing that we'll be dealing with. Typically, we will be looking at site access and determining, firstly, can we actually get a drilling rig into the borehole locations with the plant that we've got? And are there any other requirements with the site access? We might, for example, want to put boards down to minimise disruption to the surface. Another thing that we're considering is the working space. So quite simply, do the drillers actually have enough space to work? Do they have enough space to pull the steel rods which go in and out of the hole? Do they have enough space basically to do that safely? And obviously that will be done in tandem with the rams. We'll also consider the borehole positions and the borehole spacing. Are the boreholes spaced appropriately apart? Generally speaking, the installer will request those are spaced 8 metres apart, if not more, to minimise thermal disruption between the two boreholes so they can operate as efficiently and effectively as possible. We also as well ourselves recommend that distance is kept back from your property. So in our case, we may recommend no closer than 10 metres. In some circumstances, that might not be possible, in which case we'll assess additional requirements, should that be the case that we need to drill closer than the 10 metres. We'll also assess, as mentioned before, the underground services, namely that's your gas pipes, your power pipes, any water pipes, and any fibre optic cables which are running underneath the ground into your property, because quite clearly we don't want to be drilling through any of those. Another thing that we're considering are any trees and any roots which are located in the property. Obviously, we don't want to be drilling close to trees and drilling through roots and things like that. So what we'll usually do is recommend that we keep the spacing of the boreholes away from the potential zone of influence on those trees. In terms of geology, this is a big factor for a drilling contractor. You know, what we're drilling through, you know, in terms of soils and gravels, what kind of rock are we drilling through as well? It might be harder, it might be softer, it might be more firm, it might break up. So we need to assess that in order to determine basically what the actual cost of drilling is going to be. And another thing, in certain areas of the country, certainly in the central belt of Scotland, in Ayrshire, Glasgow, Edinburgh, Lanarkshire and Fife, there's a lot of historic disused underground mine workings underneath the ground at shallow depth. Those are the responsibility of the coal authority. So depending on where you're drilling, you may need a coal authority permit in order for drilling to take place. There's also environmental regulations in place for drilling, and those are governed by the appropriate body, depending on where you are. In Scotland, it's SEPA, the Scottish Environmental Protection Agency. In England, it's the Environment Agency, and I believe in Wales, it's the Natural Resources Wales, but Andrea can correct me on that. In addition to that, just to stress again, that there is a vertical borehole standard developed by the Ground Source Heat Pump Association, which is basically a set of guidelines which is for good practice while drilling for ground source installations. And I'd recommend that anyone who is looking at an installation considers those standards and ask if you'd like to see them. For an open loop system, as we covered earlier, that's governed through the code of practice, as I mentioned. One more thing to point out, which is the potential for artesian pressure. That is basically when you drill into the ground, sometimes water may arise from the surface, and it's important to consider the potential for that before drilling, and also any particular measures for mitigating that while drilling on site if it's unexpectedly encountered as well. So based on all of that, basically the driller is going to determine the optimal drilling rig, the drilling techniques which they'll have to use on site, any additional equipment for the project. Some may require, as well as the drilling rig, a compressor or water pumps and tanks and things like that. They will need to consider all of that while giving you a price, which will be calculated and, as I've mentioned before, be given to the installer or the designer so they can give a turnkey solution for the installation of the system. So onto the installation itself. What do we actually do when we're installing a borehole for a closed loop system anyway? Well, traditionally what we'll do is we'll mobilise the site. Firstly, that is getting the rig and all the equipment to the site, getting the crew to site. and then setting up at the borehole location. So making sure the borehole, the rig is over the borehole in the correct location, making sure all the equipment is laid out in the right places, make sure that everything is safely in place. And once we begin drilling, what we'll do is typically drill potentially up in Scotland in a slightly larger diameter for the first section of the hole. Now, the reason for that is that typically up in Scotland at the very least, you'll have a layer of drift before you actually hit the rock beneath the ground. Now, basically what that means is that there are soils and gravels and boulders, even clays, which sit above the rock under the ground. And typically what we'll have to do is drill through that drift and install what we call steel casing temporarily into the borehole, with the objective of holding the borehole open, because otherwise there's potential that parts of that drift could collapse on top of the rods while you're drilling. So the casing, the steel casing, is installed temporarily, basically to hold that borehole open while we're drilling at greater depth. So as I mentioned, we'll then drill through that. We're then into the bedrock beneath the drift. And obviously that can vary largely depending on which part of the country you are. Generally, the further north you go, the harder the rock may be in certain places, and generally the thicker the drift may be in certain locations, certain places. The further north you go, certainly the further west as well. So we'll drill through the bedrock to the target depth, and it may be that the target depth is anything down to 200 meters below ground level. Once we've drilled the borehole, what we'll then do is pressure test the vertical collector loops, the polyethylene 40mm pipes, which will go within the borehole, and we'll install those, we'll pressure test those loops. And then once they're pressure tested and presuming everything is satisfactory, we'll then install those to the target depth. And once those are installed, what we'll then do is pressure test the loops once more, and that's basically to check for any potential damage during the installation of the loops, which in our case is rare. Certainly we've not had any experiences of it, but it's always good to check, and those are part of the guidelines which are, as I mentioned, laid out through the Ground Source Association. Presuming everything's good with the loops and we've been pressure tested and they tick all the boxes, what we'll then do is fill the borehole. Normally that would be with a grout, usually a thermally enhanced grout, which will fill the borehole from the bottom up to the surface. And what we'll then do is leave the collector loops ready for onwards connection. You may have some borehole drilling contractors who will also do the trenching of the pipes towards the manifold, which obviously connects all the boreholes up together. And they may do the trenching for that. Some won't, some will. It really depends on the contractor. All this, that's for one borehole, solution, and so on, and repeat those steps again. Just to cover very briefly, an open loop system, which is the abstraction of water from the ground, that's obviously a completely different type of installation, and that basically involves drilling a borehole in much the same way. But the difference is that instead of installing U-tube collector pipes within the borehole, what you're doing is installing a submersible water pump at the bottom of the borehole. You're also installing a well screen, blue well screen liner to line the borehole, basically to protect it from sediment infiltration. The pump at the surface will be connected normally to some form of riser pipe with electric cables connecting it to the surface as well. And again, the borehole will be ready at the surface for onwards connection. So just to round up, benefits of ground source, if any of you are looking at a ground source system and you're interested to know how it works, and you want to take it further and you think it potentially could be a good option for you, ground source is basically an efficient low carbon heating system. The system doesn't burn any fossil fuels directly to provide heat to the property. So it's a clean solution which is capable of providing heat very efficiently. And there is also the potential as well, if you look to put solar panels on the house, that could power with the electricity, power the heat pump directly as well. So it's 100% renewable. As I mentioned, the heat source is consistent all year round, particularly at deeper depths. So unlike potentially other heat pump solutions where there may be some sort of variance in the temperature during different times of the year, with a ground source system, you're going to get a consistent temperature, so there's certainty that you're going to get that heat. And it's also an adaptable system as well, because ground source systems, certainly the more modern systems, can also provide cooling as well as heating for the property. So that is, if you get one of those kind of rare warmer days in the Scottish summer, you can basically put some of that heat from your warm property and store it in the ground to cool your property. A ground source system typically will have a longer lifespan as well. Certainly if it's properly installed by an accredited supplier and it's been done properly. Certainly the above ground works can last for potentially several decades. The borehole array could, if it's installed again properly, last potentially up to 100 years, if not more. There's also no parts visible externally, generally with a ground source system, and then the image on the right kind of demonstrates that. That's at a new build house, which actually has 4 boreholes sitting underneath the ground at the location shown on the image. But you wouldn't know it, basically. It's all underground, the manifold's underground, so there's no visible parts, there's no visual disruption to the property. Aside from that, just as a couple of other points, I mean, there is general energy security there. You're not reliant with importing of any fossil fuels from anywhere else off site. The heat that basically you're generating is from your own property, which is quite a nice thing to think about. And also on top of that as well, generally speaking with a ground source system, certainly on the installation side, there will be a local or national supply chain which are ready to help you, whether that be an installer, whether that be a designer, whether that be a drilling contractor. Generally speaking, there will be people on your doorstep who are ready and willing to help. So aside from that, you're also going to be investing money in the local or national economy as well. So there's a range of different benefits to putting a ground source system in, and those sort of touch on some of the key ones. And that's pretty much it. So I've got my contact details on the screen now. If you want to get in contact with me directly, obviously more than happy to chat. Yeah, ready for any questions.
Okay, thank you, Robert. If you could unshare your screen for me,
Sure.
that'd be great. Thank you. That was interesting, and we do have a couple of questions.
Sure.
We have one from David, which begins with, what is the point of ground source heat pumps? I hope that we've answered a part of that question for you, David. But if you would like to email in to admin@gshp.org.uk with that one, because that's not really the forum here. We don't really have the time for that here to go through that. So if you could email that in, that would be great. Rebecca's saying, could you have confirmation that CP3 is designed mainly for large-scale systems and not microsystems? When that question came in, I've actually just sent a couple of messages to people to clarify that for us. And one was one of the main authors of CP3 and another one from our association. And they're both telling me that their guidance, most of this, the CP3 is for guidance for all systems. But again, Rebecca, if you want to email any specifics in, I can get the people concerned to contact you directly, just to clarify that for you. And then the last one I have, I think, is from Emma saying, is this going to be available afterwards? Because I'm taking copious notes. So yes, we were live. It will be on YouTube. And we've also, we also have a link on our Ground Source Heat Pump Association website. So once Stephen's done the editing later on, then that will be available as well. Somebody else is just asking, what diameter do you drill the boreholes at, Robert?
Yeah, so I mean, it really depends on the type of installation. I mean, typically for a closed loop system, it will be 120 millimeters, which is just over 4 inches in size. For an open loop system, potentially it could be a lot larger than that. It really depends on the type of system that you're installing for open loop. I mean, we ourselves are capable of drilling to diameters of 300 millimeters, which is 12 inches, potentially more than that, if the requirements mandate that it's necessary. But generally, for a closed loop system, it will be 120 mil or 4 3/4 inches.
Okay, thank you. So I think that's all. We don't seem to have any more questions. I would like to say thank you, Robert. That has been interesting, and yes, I think everybody else will have found that of interest as well. So thank you very much, everybody, and I hope you enjoy the rest of your day. Thank you.